not audible. I can see your mic on, but you're not audible. Okay, so last time we did till the basic chemical kinetics, and today we are going to move towards the integrated rate law equations. Okay, and so in integrated rate law equation, first of all, we have the zero order reactions, and there are a few equations that you have to remember for zero order reaction, first order reaction, and then in general nth order reaction also you can remember. But zero order, first order, you don't have any choice. I mean, I hope you can you remember them from the class 12 syllabus itself. So for the zero order reaction, the rate, it will be equal to the rate constant and the concentration of the reactant to the power 0. So that defines the zero order reactions. The integrated rate law equation, once you integrate it, it will become equal to what? Is equal to A naught minus KT. Now it's very important to remember that this, when we write A, it is equal to A naught minus KT. This, what is this A? This A is actually the reactant that is left. Okay, this is reactant remaining, the remaining amount of reactant. Okay, it's very important. So sometimes they will ask you the amount reacted, and people and students generally, what do? They calculate the reactant that is remaining, plugging in all the correct form. Like they are plugging everything correctly. Okay. And then they will be asked, like, what is the amount that has been reacted? And they will answer the reactant that is remaining. Also, this type of question, that how much amount is reacted, can be asked without giving the initial concentration. Okay, without giving the initial concentration. If you see here, the zero order reaction, this equation is very interesting, that this is the initial amount of the reactant and this is the reactant that is remaining. So if I just put KT there, so KT will be equal to A naught minus A. This is initial and this is remaining. So obviously KT will give us what is the amount that is reacted. Okay. So if you have been given the rate constant and time, if you have been given the rate constant and time, then you can calculate the amount reacted. You don't need what the initial value of the concentration. Okay. So please remember these points also, that you don't need in zero order reactions only. You don't need the initial amount of the reactant in order to calculate the amount of reactant that has reacted. For amount remaining, you need the initial concentration also. Okay. So this is about the integrated rate law equation and what type of questions can come. Then we have T half. T half is what? The time taken for the 50% completion of the reaction. Completion of 50% of the reaction, it is equal to A naught by 2K, directly proportional to the initial concentration and inversely proportional to the rate constant. And since this is T 50%, T 100% will be equal to, this is by A naught by 2K, you multiply this into 2, you will get A naught by K, that is the T 100%, that is the double of the T half. Okay, so these are a few equations that you have to remember. Now, when you look at the graphs, so first graph is between the concentration and time. So concentration will decrease as the time increases because more and more reactants are getting reacted. So the amount of reactant will decrease. Then X, what is X here? X is the amount that is reacted. So as the time increases, the amount reacted will increase because reaction is happening and more amount of reactant is getting reacted. Then next, we have the rate versus the concentration. Since the rate does not depend on the concentration of the reactant, it is a straight line that is parallel to the x-axis. Then we have T half, as we see that T half is directly proportional to A naught. So as the concentration, initial concentration increases, the T half is also going to increase. So these are the few graphs for zero order reactions. Then we have first order reaction. Now, in first order reaction, you have to remember also point that all the radioactive decay that is going to happen, it is going to happen through the first order reactions only. The integrated rate law equation is KT, that is equal to 2.303 log A naught by AT. Again, here A naught is initial concentration, AT is the concentration that is remaining concentration. Now, there are a few graphs. In graph, we have log A naught versus the time. In this case, it is a decreasing slope graph with an intercept, and this intercept, it is going to be log of A naught. Right? Then we have the T half. Now, T half, you must know that it is equal to 0.693 divided by K, and it is not proportional to, and it is not dependent on the initial concentration. So that is why it is a straight line. which is parallel to the x-axis, where x-axis is the initial concentration. Now, when we talk about the rate and concentration, since rate is directly proportional to, as you can see here, first order reaction R is equal to what? K into the concentration of A to the power 1. Since rate is directly proportional to the concentration of the reactant, as the concentration of reactant increases, the rate will also increase. Now, this is the nth order, like this general equation is there for any order, and this it satisfies each and every order except the order 1. Okay? It is not valid for first order reaction, it is valid for every other order of reaction. Now, one thing that is very important here is the general T half. So in general, you can have T half as T half is directly proportional to 1 upon A naught to the power n minus 1. Okay? T half, it is directly proportional to, I can say 1 upon A naught to the power n minus 1. Now you can see this particular equation in certain other forms also. T half is directly proportional. So when I make this denominator, if I shift it to numerator, the powers will change their signs. So this whole thing will become minus. So you will get A naught to the power. This n will become negative and 1 will become positive. So it will be 1 minus n. Okay. So whatever form, it is the same thing. So please write a few things here. Write this equation. Okay. And also from the zero order, you have to write these equations. And this equation for T half. Although half for half line, I'll be doing separate sections, separate questions for half line, but please write these equations now. Done everyone? Anyone still writing?
Yes,
Anyone still writing? Tariq is writing. Maria, I was waiting for your doubts. What happened?
Sir, I couldn't save your number.
Okay. Save it right now.
Sir, what is in the doubts? Can I send in the after, sir?
Sorry, what Tariq? What did you say?
Sir, I forgot to send doubts. Can I send the doubts after, sir?
You can send doubts anything. +917530998007. this is my number. Now, there's one thing that we need to do now is first order reaction when all the reactant is in what is in gaseous phase. Okay. So let me just make some space here. So let us suppose we have certain gas here. A, and it is giving you B plus C. So all of these species are in gaseous state. Okay. Now we have three things. We have initial, and then there will be some change, and then there will be equilibrium. Now please don't worry about equilibrium. Equilibrium means the final state, because I mean there is nothing actually happening. Something is happening at equilibrium, and it is dynamic in nature, but you cannot see a significant change at equilibrium. Concentration and everything, all of these things, what they remain constant. So this is what initial change and then the equilibrium. So initially we will have only P initial, that is due to what? The A gas. This will be 0 and this will be also 0. There is nothing of B and C. When I look for change, then let us suppose X amount of A has reacted, and due to that the pressure of A will decrease by X amount. I am doing minus X here. So for B, there will be increase in X amount and there will be increase in X amount for C. Now at equilibrium, what is happening? Pi minus X, this is X and this is X. Now the P total, if I say, what is P total? P total is the pressure at equilibrium. P total will be equal to Pi minus X plus X and plus X. Right? This is Pi. Now at equilibrium, that means finally we have A, B, and C. The pressure due to A is Pi, that is P initial minus X and X. Fine. Now X and X will cancel. We'll say that P total, it is equal to P initial plus X. Now, one thing that is very important for all of you to understand is that we can measure the P initial. You have inserted the A gas and you are measuring the pressure. You can measure it. P total also you can measure, because after some time what will happen? A will dissociate, it will give B and C, and P total also you can measure it. What we cannot measure is what? We cannot measure the X. That is why we write X, it is equal to what? X will be equal to P total minus P initial. Okay. Now we have written everything. Now we are going to write the rate equation. So what is the rate equation for first order reaction? It is Kt is equal to 2.303 log of A naught by A. A naught by A. Now, when we write A naught by A, what is A naught? The initial concentration divided by the final concentration. In terms of pressure, if I write, what is the initial? Initial, it is equal to Pi. And what is the final concentration? What is the remaining concentration of X? It is Pi minus X. Now this will be equal to 2.303 log of Pi upon Pi minus, if I put here, it will be P total minus Pi, and this will be equal to 2.303 log of Pi upon now Pi minus P total plus Pi, because when minus will, I will open the bracket, minus minus will become plus, and Pi plus Pi will be 2Pi minus P total. ठीक है, इसको ऐसे हम लिख सकते हैं 2Pi minus P total. So this is the formula for what? For first order reaction in gaseous phase. Please copy this down. Chavez, why are you late every day? जी Chavez, what happened? लेट कैसे हो रहे हैं आप डेली? Are you here or not? चलिए. All of you done writing is please tell me. Anyone still writing? Anyone still writing?
No, sir.
No. Everyone done? Okay, let us see the first question. See, this question is directly the same thing, na? The integrated rate law equation for first order gas phase reaction is given by where Pi is initial pressure and P total is the total pressure at time t. What's the correct answer? Tell me, guys. ध्यान से देखिए तारीफ. ध्यान से देखिए.
Yes, I said.
हाँ, नाउ इट इज ठीक है, अब ठीक है. ओके, मारिया, शाहिद, मदीहा. मदीहा सही से देखिए. मारिया, शाहिद एंड तारीफ, नॉट इज फाइन. यस, फादिल करेक्ट. मदीहा, सीट प्रॉपर्ली. सही से नहीं लिखा क्या आपने?
No, it's C only, right? Pi by
अच्छा ठीक है, फाइन. रीड व्हाट वी डिराइव्ड ना. कैन यू प्लीज रीड इट?
KT is equal to 2.303 log Pi by
Log. Where is the log in C? Wait. Where is the log in C?
Sorry.
याद फिर से देखिए. याद. नो नो. हाँ, फादल, योर्स करेक्ट. योर्स इज करेक्ट. मदिया फाइन. याद. हाँ, इतना टाइम लगेगा डायरेक्ट क्वेश्चन में भी. चलिए ठीक है. थोड़ा ध्यान से बस, है ना. हड़बड़ाइए मत आप लोग, ठीक है. आई होप थोड़ा मैथ्स आपको पता है कि यू हैव टू डू लाइक 10, 12, 9, 10 ऐसे सही सवाल करने हैं आपको, सो यू हैव टाइम. चलिए, ट्राई दिस वन. They've given the rate of first order reaction at 10 minutes, and this is the rate at 20 minutes after the reaction has occurred. They're saying the half-life of the reaction is dash minutes. You can calculate the K from the given values, I hope. Yeah, is getting as yeah, that is fine. Correct, yeah. Yes, Maria, nearest integer. Yes, Maria, that is also correct. Okay. So I hope you guys have done like this. Na? K is equal to 2.303 divided by time 10 minutes, and then here we have what 20 minutes, right? So here what we can write, divide by 10 and log of, now initially what is the rate? Initially the rate is what it is, 0.04, and then finally the rate is how much, 0.03. Now we know that rate is directly proportional to what, the concentration of A. That means whatever concentration of A will be reflected on the rate when we are in the first order reaction. See, this is the only point that you have to understand. ठीक है, या फिर उससे भी आपको नहीं समझ में आया, देखिए ऐसे समझ लीजिए आप, R is equal to K into the concentration of A at time 10 seconds. This is the rate. ठीक है, rate at 20 will be equal to, the rate constant will be same, A at 20 minutes. ठीक है, now what I am going to do, what we need this term, right? We need A naught at 10 divided by A naught at 20, initial, final. So this I can write as what? I can write this as, if I divide both of these things, A naught by 10 will be equal to, let me write it like this, wait a second. I'm getting confused right now. R10 upon R20 is equal to K into A10 upon K into A20. Fine. So K and K will be getting cancelled. A10 upon A20 is equal to R10 upon R20. So even though here they have not given us the concentration, they have given us a rate, but we can directly use the rate because of this particular relationship between rate and the concentration. So log of, we will write R10. R10 is what, 0.04 divided by 0.03. Okay. Does this make sense, everyone? Those who did not
Yes,
start
sir.
this question. Okay. Now you
Yes,
can
sir.
calculate it. Now K, if you can calculate. Yes. Any questions? Shavez, Shahid, Tariq?
No, sir.
No? Fine. K, it will be equal to how much? 2.303. If you calculate this term, it is coming as how much? 0.028, I guess, right? 029 per minute inverse. Okay. If you calculate this term, it will come as 0.029. Now, once you have got the K, it is, now the T half, it is equal to 0.693 divided by K. Okay. Therefore, K will be equal to 0.693 divided by K, and K is 0.029. Okay. And once you divide both of these numbers, you will get the value as, so not K, this is T half, my bad. This will be equal to 24.096 or 09, something like that. So the nearest integer is 24. Copy this down. This is important here. This is, I mean, this is the only thing that they are testing. बाकी ये तो आप लोग को पता ही होगा. Maria and Iyad, you did the same way?
Yes, sir.
So,
Anyone still writing? Anyone still writing?
No, sir.
Should we try this? Okay, majority of the questions that I will be bringing here will be numerical types, at least in the physical chemistry part, because MCQs में तो थोड़ा सा आप लोगों को मतलब hint मिल ही जाता है. What I understand is that MCQs you may be comfortable, but you may have problem in numerical type. That is why I'm bringing more of numerical type questions. ठीक है, rather than MCQs, at least in physical chemistry. Just give me a second. Okay. The following data were obtained during the first order thermal decomposition of a gas at a constant volume. So this is the pressure at time 0, and this is the total pressure. The rate constant for the they are asking for the rate constant. ठीक है.
The first one is the initial pressure, right?
Sorry, this one.
Yes,
This is
sir.
the initial
The
pressure.
first
Yeah.
one. Yes.
Yes. Yes, yeah, correct. Waiting for others. Maria, check your calculations. Don't think it is correct. So you're having A, which is giving you 2B plus C. Okay. So initially you will be having 0.1, and this will be nothing, this will be nothing. And there will be minus x plus 2x and plus x. At equilibrium, you will be having 0.1 minus x. This will be 2x, and this will be x. The P total will be equal to 0.1 minus x plus 2x plus x. X and x will cancel. This will be 0.1 plus 2x. And P total is 0.28. So from here, you can calculate the value of x and 2x also. So 2x will be equal to 0.1 will go there. 0.28 minus 0.1. This will be equal to what? 0.18. And x will be equal to 0.09. Fine. Now we have, once we have got the A, this is the initial, this is the final. You can plug this in the final, and you will get K. We have to find K is equal to.
Sir, like we can directly apply the formula.
Yeah, you can directly do it.
Okay, sir.
Zero 0.2 and divided by 115 log of initial is 0.1 divided by 0.1 minus 0.09. ठीक है. Once you calculate this, Maria, your calculation, you checked your calculation.
Yes, something went wrong in between.
0.1 divided by this will be what? 0.01, I guess, right? Zero 0.01. It will be equal to 2.303 divided by 115 log of 1 by 10, and this is 100.
Getting 1.5.
So this will be 1 by 100. So this will be equal to K is equal to, this will be 10, no? 100 will go that side, and log 10 is equal to 1. So it will be 2.303 divided by 115. This will approximately be equal to, like, if you do some approximation, this will be 2 divided by 100. So it is 2 into 10 to the power minus 2, approximately speaking. Chavez, you are saying something?
Sir, I'm getting 0.0.
Turn your mic on properly. I cannot hear you. You got 0.0?
1. Sorry, sir, some error in calculation.
Okay. I think you will have to calculate the x. If I use here 0.2 minus, that will come into negative. Okay, so you'll have to calculate the x here like this, because here we are having 2b rather than b plus c, we are having 2b. Okay, copy this down. Anyone still writing? Anyone
Yes,
still?
sir.
Yeah. Okay. Tariq, let me know once you're done.
Yes, sir. Done.
I'll try this. A student has studied the decomposition of a gas AB3 at 25 degrees Celsius. He obtained the following data. It is at different pressure, that means different initial concentration, and then you are having the T half. We have the formula now. T half, it is proportional to 1 upon a naught to the power n minus 1. Okay, so you have here various values of T half and various initial concentrations also. These are what pressure and gas. So for gas concentration, okay, so try to do T half upon T half for 2 equations and you will get it. I'm going to give you guys 1 minute, 2 minutes for this. Okay, yeah, okay, yeah, GG, correct. Yes, Shahid, correct. See, let us suppose T half of first experiment divided by T half of second experiment will be equal to 1 upon this will be P naught n minus 1 divided by 1 upon P1 P2 कर देते हैं हम इसको, because it is 1 and 2, P2 to the power n minus 1. This will be equal to T half of first divided by T half of second. It is equal to P2 up will be going up, P2 n minus 1 divided by P1 n minus 1. Now since the powers are same, I can do it like this. है ना, P2 upon P1 whole to the power n minus 1. ठीक है. Now we have T half. अब किसी को भी ले लीजिए, 50 and 100 कर लीजिए आप. This will be equal to, my bad, I have to write the T half here. Na? T half is for 50 it is 4 and for 100 it is 2. This will be equal to, for second it is 100 divided by P1 is 50 to the power n minus 1. So 2s are and here we have 2. It is equal to 2 to the power n minus 1. So 2 to the power 1, it is equal to 2 to the power n minus 1. That means I can say 1, it is equal to n minus 1, and n will be equal to minus 1 will go that side, it will become 2. So n is equal to 2. So the order of the reaction is equal to 2. Yes, Maria, correct. Please copy this down. Anyone still writing?
Yes, sir.
Tarif, let me know once you're done writing.
Done, sir.
Done? ठीक है. Here, this is the rate is equal to K into the concentration A of A for a reaction. 50% of A is decomposed in 120 minutes. The time taken for 90% decomposition of A is dash minutes. ठीक है. यहाँ पे बस one thing is there कि how do you know what is the order? So they have given you the rate equation. ठीक है. R is equal to K into the concentration of A to the power 1. यहाँ पे वहाँ power क्या है? 1 है. That is why the first order reaction is there. So from first order reaction, from T half, you will calculate the K, and once you get the K, you can calculate for 90% decomposition. ठीक है. अब ध्यान दीजिएगा जरा. Whenever you have percentage decomposition, 90% has already reacted. So what A naught you have to take? A naught will be equal to 100. ठीक है. And what will be the K? K will be equal to 0.693 divided by 120. Right? This will be in minutes. And what will be the remaining concentration of A? The remaining concentration of A will be
50.
10, because 90 has already decomposed, 10 is remaining. So from the equation, you will put what we have to calculate, time. No? So time, it is equal to 2.303 divided by K log of 100 upon 10. Now, this is equal to 2.303
So
divided
time
by
is 120, right?
0.
So
Time is not
is
120 now, so T.
like for
पढ़िए,
50%.
पढ़िए. So this is T half here. K is equal to 0.693 upon T half, no, Shavis?
Yes.
T half is equal to 0.693 divided by K. So K will be equal to 0.693 divided by T half. Make sense?
Yes, sir. Yes, sir.
So K will be equal to 0.693 divided by 120. It will be multiplied here 120. Log 100 upon 10. So it's 10, and log 10 is equal to 1. So this is the time you can calculate it. By the way, any idea what is 2.303 divided by 0.693? This has a relationship either, these two things. You can, for example, this will be, you can cancel these two by multiplying 0.3. 0.693 divided by 2.303, it is equal to 0.3. ठीक है, this has a relationship. इसको आप एक बार calculate कीजिए, you will get an approximate value. 384 नहीं होगा शायद. It will be close to 400. It will be like very close to 400. Because if I do this now, this is approximately equal to 0.3
Yes,
and 0.3.
398.9.
How much is
398.9.
398? हाँ ठीक है, 398.9. So that means 399 will be the correct answer. ठीक है, 399 will be the correct answer. हाँ मारिया correct. So in numerical types, you please take your time. Don't be in a hurry. You are going to have you will be doing only 5 questions of numerical type, right? So please take your time and get the correct answer, exact answers. Anyone still writing? Anyone still writing?
No, sir.
Try this one. The time required for completion of 99.9% of a first order reaction is dash times the half-life of the reaction. ठीक है, तो यहाँ पे you have to do again the comparison. We know that T half is equal to 0.693 divided by K, and T 99.9% it will be equal to divided by K log of initial is 100 divided by 0.1. ठीक है, कीजिए अब इसको. Whatever value comes now, you have to then compare T half and for this one. 2.303 divided by K log of, this will be what? 1000. So this will be equal to 3 into 2.303 divided by K. Now 2.303 and 0.693, it is again approximately equal to how much? This will be, we'll have to divide it. Divide it. Acha, 3 times. No, 3 is not the answer. Here we have 0.693. Na? ऐसा कीजिए that you have T 99%, 99.9 divided by T half. It is equal to, this is 3 into 2.303 divided by K, and this is 0.693 divided by K. So K and K will be cancelled, and you will get the answer as T 99% is equal to T half multiplied by 3 into 2.303 divided by 0.693. So 2.303 and 0.693, it is approximately like 0.3. Okay. So, and this is 10 times. Okay. The answer will be 10. Yes, Maria, correct. No, Shavis. एक बार देख लीजिए इसको. If you have doubt, then please let me know. T 99% is equal to T half into 3 into 2.303. 2.303. If I multiply 2.303 into 0.3, this will be equal to 0.693. Okay, approximately. So 2.303 divided by 0.3, and in the numerator we already had 3 upon 0.3. This will be equal to what? 10. Okay. Now there is also one more way to do this without any calculation, but that is not a very concrete way of doing things. So you take a kind of a number line type of thing, and this is your T half, like this is the 50% completion. Then again from 50 to 75% completion, it will again take the same amount of time, right? Because first order, it does not depend on the initial concentration. So for half-life, for example, if the initial concentration was half, so in order to get 50, it will take the T half time. From 50 to 25 also, it is going to take the same amount of time. So now after 75, how much is remaining? 25% is remaining. So half will be 87.5. 87.5. So this will again take what? The same amount of time. Now how much is remaining after 87.5? We have how much remaining? 12.5. 12.5, that means half will be 6 point something. So if you add 6 here, it will be 93. 93, 94, right? Somewhere here. So after 93, 94, again 6% is remaining. So like this you have to do, but 99.9% it is very tough to find. But if they asked for 75%, you can easily tell that it is twice the time required for 50% completion. Okay. I think there is one question of this type also. Anyone still writing this one? Is anyone still writing? No. That is the half-life of a radioisotope bromine 82 is 36 hours. The fraction which remains after 1 day. From half-life you will get the K. Okay. Yes, radioisotope means first order. E naught, by the way, you will take it as one initial concentration, one लीजिएगा, ठीक है ना? You have to find the final concentration. You take 2 minutes for this.
Sir, we don't have to convert, right? Like hours into minutes.
No, you don't have to convert that, but the fraction which remains after 1 day they are asking. So the time they are seeing, it is 24 hours. So you have to convert 1 day to 24 hours. Please remember this 36 hours is not the time, it is the half-life. So from here you will what get? You will get that K, that is equal to 0.693 divided by 36 hours. This is not time, please remember that. Okay, from here you will get the K. You have K, you have A naught, you need to find the remaining amount, that is the concentration of A. See you guys. What do we have? We have KT is equal to 2.303 log of A naught by A. We need to find this A here. Okay. Now, log of A naught by A will be equal to KT. What is K? 0.693 divided by 36. This is K. And what is T? Time is 24 hour into 24. And this will be divided by 2.303. So as we have said, 2.303, and this will be getting cancelled by 0.3. Okay. Now we have 0.3 and there we have 36. Now this can be cancelled a few things. 36 and 24. I think by 12 we can cancel 3s up, and this will be what? 2s up. Now 0.3, this will be by 10. Okay. So we have got log of A naught upon A is equal to 2 by 10. Okay. And log of A naught upon A, it is equal to 0.2. Now what we need to find, we see, if you guys know, here we have power of 10. है ना? I don't know whether you know it or not, but I'm going to directly take the anti-log. ठीक है ना? So anti-log, if I take for this left-hand side, it will become A naught by A. Right? And anti-log of 0.2, they have given us 1.587. 1.587. What is A naught? A naught is 1 upon A. It is equal to 1.587. And A will be equal to how much? A will be equal to 1 upon 1.587. So you have to find the value of 1 upon 1587. And this is, I think, approximately equal to 0.630. Okay. So the answer will be 63 into 10 to the power minus 2. Shah is correct. Very good. Please copy this down. Anyone still writing? If those who are writing, please write. Others, you can do this question.
Sir, the isotope is always first order.
Yes. Radioactivity is always of first order.
Okay, sir.
Okay, those who are done, please try this next question. Shaviz, you are done writing?
Yes, sir.
1 more minutes, then I will do this question. See, it is saying that the ratio of carbon 14 to carbon 12 in a piece of wood is 1/8 part that of the atmosphere. Okay, so there is one thing that is not given here. I mean, what is the meaning of this part? That of atmosphere. That means if I take the ratio of 14 carbon 14 divided by carbon 12 of what? Of the wood, and 14 carbon divided by 12 carbon of atmosphere. Okay, now this ratio, it is equal to 1. Okay, I hope now it is clear. Once I have written this now, the ratio of what? The ratio of this thing, piece of wood, is 1/8 part that of the atmosphere. Okay, so the ratio of this thing versus that of atmosphere is what? It is 1/8. Okay, so the wording of question is, it requires a bit of clarity, but once you read it and now you can understand that it is carbon 14 divided by carbon 12 of wood upon carbon 14 divided by carbon 12 of the atmosphere, it is equal to 1/8. Achha. Now, what information are we getting from this particular point? The information that we are getting from this particular point is, see, the carbon 12, it does not disintegrate. So whether it is in the wood or whether it is in the atmosphere, it will be the same. What we are understanding from the wood is, if 8 part of carbon 14 is remaining in the atmosphere, like right now, only 1 part is remaining in the wood. Initially, wood के पास कितना होगा? 8 होगा, right? So we can say that A0 is equal to 8 and the remaining is equal to 1. So that is the only information that this particular equation and this particular line was giving you, that A0 is 8 and A initial is what? A initial, it is equal to 1. Now, what we need to find is the age of the wood sample. Okay, so we need to find the time. So, and also we can write here the half-life of carbon 14 is given. So K will be equal to 0.693 divided by 5730 years. So KT will be equal to 2.303 and log of 8 by 1. So log of 8. So what is K? K is, the T will be equal to 2.303. And what will be the log of 8, guys? Tell me. Log of 8.
4 is power 2. 4 into log 2.
4 into?
3 into log 2.
3 into log 2. So what will be 3 into log 2? What's the value of log 2? 0.3. So 3 into 3 will be 0.9. Okay. So 2.303 into 0. K. And what is K? It is 0.693 and divide by 5730. This will be multiplied here, 5730. Okay. So 2.303, we know that this and this will go by 0.3 and this will go by 0.3 into 3 will be equal to this much. So the answer is going to be what? 5730 into 3. It is equal to 17190. Let's copy this down.
Sir, could you just explain the starting part, like how did we get A0 as 8 and A as 1?
Shavis, you will have to answer me, okay?
Yes.
Carbon 12, it does not disintegrate. That means उसका न्यूक्लियस रेडियो एक्टिव नहीं होता है. मेक सेंस?
Yes, sir.
So carbon 12 in the wood and the carbon 12 in the atmosphere, it will be the same. Correct?
Yes, sir.
Carbon 12. But whatever variation is there, it is because of the carbon 14. So carbon 14 in the atmosphere right now, it has not disintegrated. Make sense?
Yes, sir.
Okay. So, and when the carbon 14 is not disintegrated, it is what? 8. And the carbon 14 which has disintegrated in the wood, it is 1. So when the wood was initially present, okay, when the wood was initially present, at that time the carbon 14 would have been there. The carbon 14
Yes.
would have been there, and if it was there, it will be initial will be 8, and finally now what we are seeing, we are seeing only 1. Make sense?
Yes, sir. Like, sir, carbon 14 goes beta decay.
That I don't remember actually because physics. Yeah, but it goes into disintegration. So the nucleus goes into disintegration. I don't know whether it is beta decay or alpha decay. Hmm. Carbon 14 disintegration, by the way, it is there in your NCERT also. No, boards maybe have. There is one question in NCERT also regarding the age of a tree or something like that. Okay, so done everyone. Anyone still writing? Please let me know. No one is writing. ठीक है चलिए. Now in activation energy, I hope बहुत ज़्यादा आपको यहाँ पे समझने के लिए नहीं है. ठीक है. So we'll directly start with some questions. So look here. Consider the following reaction that goes from A to B in 3 steps as shown below. I think this question was also there in the 2024 examination this year only. Now they are saying that number of intermediates and number of activated complex. What is the difference between intermediates and activated complex? Intermediates are these things. Like if the reaction is not complete, na, this is intermediate and this is intermediate. Activated complex, these are the activated complex. The transition states. Okay. So I think this is there, like this is not there in your board's syllabus. Intermediates ka graph and activated complex. Activated complex, you know, because there is only one graph in the NCERT that is like this. Okay, which is showing you that this is the activated complex of the transition complex. Okay. So what option will be correct now? Tell me, guys. This becomes now very easy. So how many intermediates we are having? And they're also asking what is the rate determining step. Rate determining step is the slowest step, right? So according to this graph, what will be the slowest step?
Step 2.
Yeah, correct. So the correct option will be, these are the options 1, 2, 3, 4. What will be the correct option? The number of intermediates, it is equal to 2. Activated complex, it is equal to 1, 2, 3. And RDS, redetermining step, it is equal to step 2. ठीक है. So intermediates 2 कहाँ पे? 2, 3, 4 में है. And A is 3 in all of them. Step 2, option number B. 63. 63 क्या आंसर है? अच्छा वो पहले का आंसर है शायद. ठीक है भी है. चलिए मूविंग ऑन. देखिए ये सवाल जो है ना, This question can be done. ठीक है. For the reaction taking place in 3 steps at same temperature, overall the rate constant K. For this question you only need Arrhenius equation. If you remember the Arrhenius equation, that K is equal to A e to the power minus EA upon RT, then you can do this particular question. कैसे देखिए? They are saying the overall rate constant is equal to K1 K2 upon K3. ठीक है. So for this overall K, I can write A e to the power minus EA upon RT. ठीक है. Which is equal to K1 K2 and K3. Fine. And E1 EA1 EA2 EA3 are given. So I can write A e to the power, rather than writing minus EA, I will write how much? Minus 40. Make sense? Yes or no? Please tell me. Divide by RT. This is for what? K1. For K2, A e to the power minus 50 upon RT. Divide by K3 will be A e to the power minus 60 upon RT. Does this make sense? Yes or no? Please tell me, guys.
Yes, sir.
Okay. Now what you can do, cancel. A will be cancelled here. Okay. And this A and this A will be cancelled. Make sense? सही है?
Yes, sir.
Fine. Now we have here e to the power minus EA upon RT, which will be equal to, here we have, there are 2E, है ना? Bases are same, and here we have only 1E. So when the bases are same, for example, 2 to the power 2 into 2 to the power 3, this is equal to 2 to the power 3 plus 2 will be equal to how much? 5. Make sense? सही है ना? ठीक है. Now what we can do? E to minus 40 plus minus 50 minus, because it is in denominator, minus 60. ठीक है. जी हाँ. Fine. Divide by RT. Now when the bases are same, I can write minus EA upon RT. It is equal to minus 40 minus 50 and then 90 minus 90 plus 60 divided by RT. So RT and RT will be getting cancelled, and you will be getting this as minus EA. It is equal to minus 30. So minus and minus will get cancelled, and EA will be equal to 30. G Maria, correct. Chavez, correct. ठीक है. So let us keep chemical kinetics still here. इसको एक बार कॉपी कर लीजिए अच्छे से. Anyone still writing? The previous one, Maria? What do you need to understand? Can you tell me regarding intermediates, activated complex, or the rate determining step? Number of intermediates. Okay. Intermediates का मतलब क्या होता है? That step 1 से step 2 के बीच में, ठीक है, whatever you are finding, that is going to be your intermediate. ठीक है. So whenever you have this lower points ना, which are not reactant or product, that will be your intermediate. ठीक है. And also intermediates are formed only because they are stable. So I don't know whether you have learned it or not, but for SN1, the graph is like this. So this is the first step where the carbocation is formed. Then there is an intermediate. This intermediate is also a reactant, na? Makes sense, Maria? If you remember SN1, in SN1, the first step is formation of carbocation. I'm not saying that this is for carbocation or this is an SN1 reaction. I'm just relating it. In SN1, what happens? The first step is formation of carbocation. Then carbocation acts as a reactant, and then the nucleophile attacks on it. Make sense?
Yes.
So this kind of looks like one more reactant, and then it is forming a product. Then again, this is also an intermediate. So again, a reactant, and then the final product. Make sense now?
Yes.
Okay. We'll do a bit of electrochemistry, and then tomorrow we will be finishing electrochemistry. Okay. So without any theory, I think you can start. Jahan theory require hoga na, then I will be putting it here. So galvanic cell and rust equation, first topic. So there is an equation that is given to you guys. Now they're asking the representation. Shahid has given the answer. Okay, Maria. No, what happened to others? बाकी लोग आंसर नहीं आया देखिए. So H2 रहना चाहिए ना. So where is H2? It is there. Here, guys. What is happening to the H2? It is getting oxidized. So in the anode case, you should be having H2. H2 is in what? B, C, and D. So one of these options would be correct. Now in the reactant, we also have AgCl, and Ag is getting what? Reduced. Okay. Ag should be there in the product. It is there in all of the products. Fine. But you should have AgCl in the reactant also. It is there only in what? It is there in B and D. So from B and D, but there is no K in the overall equation. So option B is correct. Okay. Even the representation is a bit, clumsy here. You don't know where it is ending and where it is starting. But I hope you can see that platinum H2 HCl and AgCl is getting converted to H2 is getting converted to HCl, and AgCl is getting converted to Ag. Okay, I hope this makes sense. Moving on. Try this. The reduction potential of the ions are given, the correct order of their oxidizing power. So oxidizing power. If something is having a very high reduction potential, okay, please remember, if the reduction potential is very high, that means what it will do, it will get reduced easily. If it is getting reduced easily, that means it is gain electron easily. Now, if it is gaining electron, that means it is pulling electrons from someone. Okay, so it has the power. If it is getting reduced easily, that means it can oxidize very easily. ठीक है, ऑक्सीडाइजिंग पावर, इट इज डायरेक्टली प्रोपोर्शनल टू the reduction potential. Just give me a second, guys. Maria has answered and Shahid has answered. What about others, guys? अब तो आ जाना चाहिए आंसर ना. ऑक्सीडाइजिंग पावर, इट इज डायरेक्टली प्रोपोर्शनल टू रिडक्शन पोटेंशियल. द स्पीशीज which is having the highest reduction oxidizing power also. So if you look here, what is the reduction potential? BrO4 negative का सबसे हाई है, then you have IO4 negative and then you have ClO4 negative. So option number D. ठीक है, please write it down. Oxidizing power, it is directly proportional to the reduction potential. So moving on. Try this. The only thing that you need here is, I mean, it is not given right now, is the electrode potential of hydrogen. Standard hydrogen electrode, it has E naught as what? E naught is equal to 0 for it. Try this one. Guys, are you guys having difficulty? नहीं, ठीक है, fine. Yes, correct, याद. Raise your hand if you are having difficulty in this question. Oh, everyone is doing it. ठीक है. Yes, Maria, fine. Okay, guys, please see. The reaction that will be going on will be H plus, you can take half electrons, gives you H2. Okay, or I mean, if you're taking half electrons, then you'll have to put half electrons in the equation also. But if you're going to balance it out, then it is going to be minus 0. Okay, yes, Tarif, correct, but you have to give it in numbers only. No?
Okay.
You can, yes. Okay, so it will be, you have to put it in like 10 to the power minus 2 volts also. Okay, please see here, guys. So this will be equal to half electrons and H2. Now E cell is equal to E naught minus 0.059 divided by 1 by 2 into log of pressure of H2, that will be equal to 1 divided by the concentration of H plus ion. The concentration of H plus ion is what? pH, it
pH
is equal to
minus
3.
log H plus, right?
Yes, correct. pH is equal to minus log of H positive. Okay. So H positive will be equal to what? 10 to the power minus 3. So 10 is here, minus sign will go there. So you will have 10 to the power minus 3 here like this. Now, this will be equal to E naught is what? 0. So it will be minus 0.059 divided by, not divided by, but rather 1 by 2, it will go above 2 into log of 10 to the power 3. So this will be equal to 0.059 minus is still there into 2 into 3. Okay. So once you calculate this, this will come out to be 17.7 into 10 to the power minus 2 in negative. Okay. So the correct answer will be 18. So the number that you have to put is 18. I'll try this. इसको रहने दीजिए आप, इसको अभी छोड़ दीजिए, इसको बाद में करा देंगे. It was similar one, yeah. Do this one. This is a similar question. Please इसको कीजिए. The reaction is given, everything is given. So we take 2 more minutes, and then I will do this question. Guys, no answer. Which one answer? Okay, yeah, let's see. So the potential for the given half cell at 298 is minus something. Okay. So 2H plus 2 electron gives H2. This is the reaction. We have H plus and we have the pressure of H2. So E cell will be equal to E naught minus 0.05. By the way, they have given this as 0.06. Okay. Divided by the number of electron is 2. Log of, in the product what we have, pressure of H2 divided by the concentration of H plus squared. So this will be equal to E naught is 0 minus 0.06 divided by 2. Log of pressure of H2 is what? 2 divided by the concentration of H plus is 1. 1 square is still 1. So this will be equal to how much? 0.03. Log 2 is 0.30. Make sense? Yes or no? Please tell me, guys.
Yes, sir.
सही है? Any doubts still here?
No, sir.
No. What will be the answer then? Minus 0.123. 009 volts. 009. But 10 to the power 2 ही बोला ना, 0.09 होगा, 0.03 into 0.3, 0.009 ही होगा. And log 2 is also equal to 0.30. Is there any mistake? Let me calculate. 0.03 into 0.3, 0.009. ठीक है. And log 2 is also 0.30. So you'll have to put it in pressure of H2, 2 atm, concentration of H plus 1 molar. Then what else? What was the social? How will you write in decimal? So 0.9 into 10 to the power minus 2. What is wrong? What's wrong? What's wrong? There is 2 electrons. There is 2 electrons. 2 ATM is 2 ATM. So 0.9 will be the answer. I don't know. Okay. So 0.9 तो नहीं होगा, but if they're asking for integer, you will have to write 1